In this problem, I gave you a function, I gave you a. So what I want you to do is, I want you to use the first 5 terms to build the Taylor polynomial for me, and then use the Taylor polynomial to give me the Taylor series of this function. So we have to do 3 big things for each problem. So the first step is the derivative. The second step is derivative, you plug in an a, and then the third item is you have to find the term. So this is based on the red Taylor series I gave you. So do you see that in the numerator I have f of the nth derivative, so that is the derivative, and then you have x equals to a. That's why you have to plug in a, and then you have to bring everything together to find out what the pattern is in order to build the Taylor series. All right, let's start. So since I need the first 5 terms, and then n starts at 0, so I need the n be 0, 1, 2, 3, 4, so that is a total of 5 terms. So the first thing that you will have to do is you have to do the derivative. So the no derivative, then that will be the given function, which is the x raised to 1/3 power, right? And then the first derivative, still remember how to take the derivative? You have to use the simple power rule. So you bring the exponent down, and then x raised to the exponent minus 1, which is -2/3. All right, and then this, don't just leave that as a negative exponent. You have to work all the way to the end. So that is 1 divided by 3 x raised to the 2/3, so which is 1 divided by 3, and then the cube root of x squared. You have to work all the way out, so that helps you to find the pattern. You cannot just leave that as a negative exponent, right? N equals to 2, so second derivative. So you have to do this based on the previous answer, right? So this one, you bring the -2/3 down. I am sure you can do the math mentally. That is 2/9, and then x raised to -5/3. So that is negative 2 divided by 9, x raised to the 5/3. So that is -2 divided by 9, and then the third cube root of x raised to the 5th. And then the third triple prime, so that is -10/27, and then x, so that one minus 1 is -8/3, so that is -10 divided by 27, x raised to 8/3, and then -10 divided by 27, that is the cube root of x raised to the 10th, and then you have the fourth prime. We are almost done. So like I said, if the problem is nasty, you expect to get some nasty derivative. Trust me, this problem can be very cumbersome. Said the wrong word. So this one, you bring the power down, then you have -80 divided by 71, and then x raised to the -11/3. So you have -80 divided by 71, the cube root of x raised to the 11th power, right? You bring the x to the denominator, so the negative exponent is gone, and then you put that in a radical. All right, so the derivative is done, and then you do the plug-in. All right, so to do the plug-in, let me just do it right here. So I can change that to another color to give you a better contrast. So f a is equals to a, right? So we have f of a equals to a. So a equals to a is just x equals to a. Why do we have to do this? Do you see that we have a in here? Look at the red Taylor series. So for the derivative, we have to plug in the a in there. So that means a equals to a means x equals to a. So the first one is a, then you have the cube root of a, so that is equals to 2. This one, do not use approximation. Do not use approximation. We put the whole number, no approximation. Let me just put it down, all right? To alert everybody, no approximation. And then f prime of a, so that is 1 divided by 3 times the cube root of a squared. Okay, so that is equals to 1/12. I already did the math for you, so let's don't waste time on doing this. I'm sure you can get it right. So and then f double prime a, so that is equals to I will just give you the answer, -2 divided by 9 the cube root of 8 to the 5th. So that is 1 negative 2 divided by 288. And then the next one, f triple prime of 8, that is a 10, negative 10. Oh, actually, I might make a mistake in here. Let me go back to fix that really quick. It's not a huge deal. So this one, the second prime is fine. The double prime is fine. The triple prime, so when you bring this negative down to the coefficient, this is supposed to be positive, this is supposed to be positive, and then this is supposed to be positive. And then the last one, when you bring the negative down, then you will get a negative. So the f triple prime of 8, that is supposed to be a positive. You might already figure out this. So that is 10 divided by 6912. And then f fourth prime of 8, so that is equals to negative 80 divided by 145, 408. And then we will bring this together and then build the term in our Taylor series. All right, so let's go back to orange. So we have to build a table. So the table has, actually I need more line to write the term. So that is n. So we have n equals to 0, 1, 2, 3, and 4. And then the next column, I have to report the derivative. So f of the nth derivative at x. So the first one, we have the cube root of x, and then we have 1 divided by 3, x to the 2/3. So you just copy the orange result. Okay, look at the orange work. You copy the orange result over, and then the next one is negative 2 divided by 9, and then x to the 5/3, and then 10 divided by 27, x raised to the 8/3, and then negative 80 divided by 71, and then times x raised to the 11/3. And then the next one, you have to plug in the a equals to 8. So f n prime, you have to plug in that a is equals to 8. So a is equals to 8. Then we have the white result, the 112, and then the negative 2/288. So we have the 2, the 1/12, and then the negative 2/288. I'm glad that I found the previous mistake. Otherwise, that affects the next. That affects all the works right here. So 10 divided by 6912, and then negative 80 divided by 145, 408. And then the last term is, the last column is you put everything together. So you have the nth prime of a equals to 8 divided by n factorial. The n factorial never change. And then you have x minus 8, which is 8. And then raised to the nth power. So this one, you have the result of the derivative divided by n factorial, right? So n factorial is 0 factorial, and then x minus 8 to the 0 power. And then this is 1, no, not 1, actually 1 divided by 12 divided by 1 factorial, x minus 8 to the first. This is a negative 2 divided by 288, and then divided by 2 factorial, and then x minus 8 raised to the second power. Oh, if some textbooks, they are nice enough, so when you do problems online, they might ask you to fill out this table. Because I highly recommend you to organize all the work using a table, and then you'll write your Taylor series and the Taylor polynomial. And then the next one is 10 divided by 69, 12. Okay, let's make it look like a 6912. 6912 divided by 3 factorial, and then x minus 8 to the third power. The last one is negative 80 divided by 145, 408 over 4 factorial, and then x minus 8 raised to the fourth. If I ask my student to do all the works on an exam, I will ask them to fill out this table. Of course, I will give them one blank page for them to show all the work. Now, what is the Taylor series? So Taylor series is we have summation n goes from 0. I believe that this one, okay, this one, let's don't put the number up there. So on top you have f of n derivative, and then a is equals to a divided by n factorial, and then you have x minus a raised to the nth power. This one is equals to the first one, so that is equals to a 2, right? So this is equals to a 2, so that is equals to 2 plus, and then the next one is 1 over 12. So now we have to use the very last column, and then x minus a to the first power, and then the next one is a plus negative 2 divided by 288. Oh, it's not a negative 2 anymore because there is a 2 in there, so the 2 got cancelled. That is 1 divided by 288, x minus a to the second power, and then you plus, so, and then the next term you have to do some simplification. You have to take care the third factor, the 3 factorial, so that is equals to 5 divided by 2736, and then x minus a to the third, and then the last term is a plus. You have a negative, you simplify this, you have a negative 5 divided by 36352, and then x minus 8 raised to the 4th power. So this one, what number should go to the top? So here is what I would say to you. So if you put a 4 up there, then the Taylor series stops over there. But if you put an infinity, so if you put an infinity like this, what you can do is you can do a plus dot dot dot. So the Taylor polynomial keeps going. All right, so that is the end of this problem. I don't want to solve two problems in one video. I want to solve one problem per video. So in the next video, I will solve another Taylor series and Taylor polynomial problem. So that is the end. If you think that is the end of this video. If you think my instruction is helpful, let me know in the comment section below. Like the video, subscribe to my channel, share the video for me. Appreciate your help. I will see you all in the next Taylor series problem. Signing off for now.